Hello, everyone, and thank you for attending today's webinar, Breaking the Invisible Barrier, How Through-Glass Technology is Revolutionizing FWA Deployment, sponsored by Solace and NetComm. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the blue resource list widget. Near the end of today's presentation, please take 1 minute to complete the survey that opens on your screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Gabriel Brown.
Thank you, Anna-Kate, and hello, everybody. Welcome to today's webinar on how Through-Glass technology is revolutionizing FWA, fixed wireless access deployment. Terrific to have you with us. Thank you very much for coming. We're here, of course, to talk about a through-glass, i.e. through a window, fixed wireless access solution designed to overcome the limitations of traditional outdoor CPE deployment, CPE being the devices that provide your fixed wireless service. The idea is to use wireless power and data to bridge indoor and outdoor environments, but without drilling holes in a wall or running through a cable through a window opening or something like that. And of course, outdoor CPE has a major positive impact on network system capacity and on user capacity. We'll get into a bit of that as we go through some of the gains that are there, but they're pretty huge. And you know, in a good number of cases, it's a night and day type of experience and difference for the customer on their end as well. So it makes the service possible in many cases. So the webinar today is a partnership webinar between NetComm, who's a well-established CPE supplier in various different CPE suppliers, but particularly has a terrific history and customer base in fixed wireless access. And they've been working with Solace Power, a specialist technology company focused on wireless power, based up in Canada, which has been developing the core through-glass technology that we're talking about today of application in fixed wireless access. Together, they plan to discuss how they apply their shared expertise to co-develop the system we're going to be discussing today. And the aim really is to raise visibility of the solution, tell you about the status of the product development, and also like solicit input, questions, things like that. If you have a contribution or you have a particular challenge or problem that you think a solution should address, I know they're very interesting to hear it. I'm going to be here to moderate. My name is Gabriel Brown. I'm an analyst with Omdia, covering mobile network technology. In fact, I've clicked onto the agenda slide. Basically, we're going to have a very short intro. We're then going to split the session into two main parts. Our speaker from NetComm is going to go through the first section, setting out the requirements and the ask, what they need from the core technology we're talking about here to then apply it out to the different ISPs and service providers that are going to use it. I will then hear from Solace, who will go through the detail of the technology and how that is has been developed and how it's being applied to this use case. As I said, my name is Gabriel Brown. I'm an analyst with Omdia and your moderator for today, joined by two terrific guest speakers. First of all, I'd like to introduce Peter Lewis, who is Product Director at NetComm. Peter, please turn on your mic and camera and say hello.
Hi, hopefully you can see me. So Peter Lewis, I'm the Fixed Wireless Access Product Director at NetComm. You can tell by all the grey hair, I'm a veteran of the telecoms industry, being both on the network infrastructure and on the device side. NetComm is an Australian company, basically it's been around since the early 1980s, focusing on access solutions. Fixed wireless access, as Gabriel mentioned, we've been doing this a long time, 20 years of 3GPP fixed wireless access, probably one of the longest in the world. And we've got sort of devices that have been sitting out there, predominantly outdoor devices, which is where our specialty is. We've got outdoor devices sitting in some of the harshest environments in the world for over 13 years and counting. So we'll talk about outdoor in a minute, but that's me.
Yeah, good stuff. Thanks, Peter. Great to have you. And then Willem Verbiest, who is a technology strategist at Solace Power. Willem, please just introduce yourself a little bit.
Yeah, thank you, Gabriel. Hello, everyone. I've also been around in telecoms for quite a long time, mainly in access, both fixed access and wireless access, about 10 years in fixed wireless access, and I'm now helping Solace with their telecommunications strategy.
Okay, good stuff. Everyone's been in telecom a long time. I think that's kind of important, especially the two speakers. You're going to get some in, you know, get these things that are working for 13 years non-stop. You're in good hands, and you know, all that engineering history will come to bear. Peter, just set us off then with a quick background on NetComm. You said you're one of the oldest companies around in this space.
Yeah. So from a fixed wireless point of view, yes, we are. We at heart, we're an engineering, it's an innovative engineering company. We focus on solving the challenges which are not yet mainstream and commoditized. So when we look at fixed wireless access, for instance, we focus more on outdoor and new concepts and solutions like we're talking about today with Through-Glass, rather than the commoditized indoor sort of space. We do other things. We've got fiber solutions where we bridge the gap between where the fiber is and where the end user is, the last few meters. And we do home automation solutions, Wi-Fi, distribution solutions around buildings, etc. as well. So there's various things we are, but we're an access solutions company.
Okay, terrific, good stuff. And Willem, a quick background for those who don't know on Solace Power.
Solace is a Canadian company based in St. John's, which is in the far east of Canada. Core business of Solace is wireless power, and basically that's about delivering power in cases where galvanic connections are either impossible, too expensive, or just not practical. Several examples of the industry, we're doing that: aerospace and defense, telecom, automotive, and maybe just a few concrete examples. This year, we're going to have a volume automotive product on the market soon. We have solutions which are flight qualified for helicopters. And an interesting one, I think, is the wireless power to charge sensors in the middle of the sea. You can imagine that power connections on sea are not so easy, and that's where wireless power can help a lot. Today, obviously, we're going to focus on telecom, and you'll hear about that in a minute.
Yeah, okay, good stuff. So I'm going to hand over Peter for the first section here. The way this is going to work, Peter's going to run through some slides. We're going to have a little pause, then Willem will come in. If you do have questions for either of these speakers, please put them in via the Q&A tab on your screen. I'll be keeping an eye on background where appropriate and where it sort of plays into the flow here. I may try and insert one or two questions as we go or in the transition between speakers. So don't be shy, take advantage of that. And Peter Lewis at NetComm, the controls are yours.
Thank you, Gabriel. Okay, I pressed the change slide button. Okay, so fixed wireless access. Now, I'm assuming that the vast majority of the audience here understand what fixed wireless access is, providing broadband to buildings using mobile networks. I'm also going to assume that maybe you're not all technical experts at it, but at least you understand what the proposition is. Now, as understanding the proposition, the vast majority of you will probably be aware of indoor fixed wireless access with devices such as something similar to what's on the left-hand side on this slide, a box that goes inside the building with Wi-Fi and 5G, for instance, all in one box. However, fixed wireless access is much more than that. There's lots of different flavors. And in NetComm, basically, we firmly believe that one size does not fit all. All carriers have different needs, different frequencies, different propositions, different customers they're trying to reach, etc. So we believe in needing a variety of solutions. So you can see here, basically, we've got a portfolio for fixed wireless under the name of Aurus, which basically consists of both self-installation solutions, professionally installed solutions, low-gain, urban solutions, all the way up to remote, real remote rural solutions with ultra-high gain antennas. So there's a whole range of different solutions here. Now, so we're going to be talking about outdoor. I'm also going to be talking specifically about the difference, two different flavors of outdoor, which is self-install outdoor and technician install outdoor. Now, before we focus on the real topic of this, which obviously we talked about, this is called breaking the invisible barrier, which is about getting through windows, with what we call through-glass technology, I thought I'd just briefly say why it's actually important to be outside in the first place. Like I said, I assume most of you are not radio experts, but what you all are smartphone users. And you've all got first-hand experience of when your smartphone doesn't work. We've all experienced probably at times frustration with our phones where we've not been able to send or receive texts or calls or watch funny cat videos or send emails. The networks have obviously got better over the years, better coverage, better capacity, but there's still pockets for every network where there's pockets of buildings where indoor performance is not as good as we'd like it to be. Now, probably most of us have learned the hard way that when you see low or no bars on your mobile phone, you walk to the nearest window or door and preferably open it, and you experience a significant performance boost. You suddenly see the bars jump up. Now, we've learned to live with it. And in fact, over the years, for smartphones, it's not actually an issue as much because we now have other solutions like Wi-Fi calling, which kind of hides it for us. For fixed wireless access, you can't hide it. Fixed wireless access relies upon that direct connection to the mobile network and only that mobile network. And we need to achieve higher broadband speeds than your single funny cat video because you're providing broadband for everyone in the building. We also typically use higher frequencies, which got more capacity as well. So we've got issues. Okay, so we all know that mobile networks and indoor is not great. But what is it technically that makes it not great? So the first thing we have when we look at outdoor, basically it's all about location here. So outdoor is better because indoors we suffer from what we call indoor penetration loss. When radio signals pass through walls and windows, they lose strength. And they can lose a significant amount of signal strength as they go through a wall and a window. Now, windows are typically better than the brick walls, but they're both bad. And depending on the type of window, it can be really bad. If we take 3.5 gigahertz frequency as an example, that's a typical 5G capacity band globally. And we look at standard double glazing and we measure the strength of the signal received from the mobile tower just outside that glass and just on the inside of the glass, so by either side of that window, we can see on the inside, it can be only 3% of the strength of the signal on the outside of the glass. Okay, so that's a massive drop just from going a centimeter or so across the glass. Now, if you've upgraded your home or your business with low E double glazing, that could be far worse. Now, we're putting double glazing, triple glazing, etc. in our buildings because they're great for making the building more energy efficient. But the downside is they're also insulating the building from radio waves. And this is the problem that we're sort of getting more exasperated. So, but it's more than just this indoor penetration loss of why outdoors better. So if we take indoor fixed wireless, where it's all a single unit, typically the end user places the unit where it's convenient for them, not necessarily where it's convenient or the best position for the network performance. So the device is perhaps not on the best side of the building, maybe not in the best room, not in the best location in the room, and any choice that the end user makes of putting it not in that best position can weaken that signal even further. Conversely, on the outside, when you have outdoor fixed wireless access, typically the devices are higher up. They are typically placed on the better side of the building with better line of sight or near line of sight to the tower. The devices are higher out of sight, so also they typically tend to be bigger devices with larger antennas. So you have a net result, basically you have better signal strength, you have better devices, and better probability of getting the connection to the tower, which means that we can achieve what we call higher modulation rates, higher MIMO rates, etc., which essentially delivers higher end user throughputs. Higher end user throughputs obviously means happier customers, but most importantly for the carrier, it means higher network efficiency. An individual user is on and off the network faster, simplest. And because it's outdoor, and you actually also get a lot more stable service, a much more predictable service, and some carriers will use the outdoor solutions to basically provide SLA-based fixed wireless services to their customers. Now, if we actually look at real-life deployments of different flavors of fixed wireless, and the graphs here are from a friendly North American carrier who did comparisons of 3 different types of offerings. You can see as you move outdoors, we can address more customers from the tower. Now, there's 2 reasons for this. First of all, physically, we can reach further, so you can address more customers further away. But also, because of the network efficiencies, we can squeeze more customers onto the same tower. That's great for the carrier. We can also see that the average data rates per end user also increase, again, depending upon what flavor of fixed wireless they've got. And you can see in both these graphs, actually, professional install fixed wireless typically has the best range and the best data rates because the devices are typically higher up and they're bigger. From the end result of this is basically from a carrier perspective, you have higher network efficiencies, you have higher revenues, you have happier customers with less churn, and from the end user point of view, basically you have higher data rates and a more stable user experience. So it's kind of a win-win for both the carrier and the end user alike. But how does outdoor fixed wireless work? Well, if we compare it simply to the indoor, I've mentioned before, it's all in one box, 5G Wi-Fi, one box. You take it home, you put it on your windowsill or your desk, you plug it in, hey, presto, you got service. And you can understand why it's been very popular. With outdoor, we separate the 5G modem from the Wi-Fi router. We put the 5G modem on the outside where it talks to the mobile network, and we put the Wi-Fi router on the inside where it talks to your devices. But we have to connect the 2 up. And to connect the 2 up, we use a cable. We use an Ethernet cable. And to power the 5G modem, we put power over that Ethernet cable. So with outdoor, the key challenge is we need a cable. And that cable needs to traverse the boundary from inside the building to outside the building. It's that traversal which is the key challenge here. I've also mentioned we've got 2 flavors of outdoor fixed wireless, which is the self-install and the technician install. Self-install has only been around a few years, whereas professional install has been around 20 years. Our definition, the NetComm definition of self-installation, would be a solution that any adult member of a family or enterprise can install. No specialized skill sets, everything you need is in the box. You don't need power tools, you don't need ladders, etc. So typically, a self-installation solution would end up being a small, lightweight device. And to bridge that gap from inside to outside, we would give the user a flat Ethernet cable where basically they route it through a window. With professional installation, you're obviously sending an engineer to site. They bring ladders, they bring power tools, they install large units much higher up on the building or the roof. And of course, they still need a cable to connect the 2 ends up, but there traditionally, the technician would drill a hole through the external wall. Okay. Now, if we look at self-installation, if we look at what we've learned over the past few years with deployments of self-installation, and here in NetComm, we've actually got some access to some very interesting data. We've got access to data from what we call user experience testing, where we visually observe people going about the process of unboxing and installing devices. But we've also got access to in-field data, statistical data from real-life commercial deployments of a wide range of users. The one underlying fact that we see with self-installation is end users are lazy. It's all about convenience for the end user, not about getting the best possible performance from a network carrier. The end user is focused on putting it where they would prefer to put it if they can, as long as they can get good enough performance for what they need. So it's not about the top speeds, the best performing, it's about adequate performance for the end user. And we can see this. For instance, there's 2 charts here. One on the left basically is showing that even though we're giving users outdoor devices, a significant portion of the users deploy it indoors. Why didn't they put it on the outside? On the right-hand side, despite encouraging the user, giving them instructions, giving them how to process and tools and apps, etc., to go about the process of making measurements at different locations around their building to find the best location, 50% of them don't bother. They've got a predetermined location in their mind. That's where they put it. And for those people that do go around their building and find better locations, they still revert back to the location where they wanted to have it in the first place, their living room or their office, etc. So if as an industry we can convert that, so from being indoors to outdoors, or converting it from being, rather than an adequate location, but to a best performing location, this can radically improve the network efficiencies of the carrier. It's got lots of value for the network carrier here. But why? Why are the end users not putting it in the right places? And now, this is all about the cable. Now, a flat Ethernet cable is a very simple proposition. Flat Ethernet through the window, simple proposition. You open the window, you push the cable through, you close your window. Technically, it works. It's great. The reality, however, is a lot more complex because, well, people like Windows. People use Windows. People like to open Windows. People are concerned about the aesthetics around their homes, etc. They don't like dangly cables. If you put something on a window, you open a window, you've got to think about actually, you've got to have some loose cable so the window can actually open. So there's some more complexities. As a CPE vendor, we've actually had to become pseudo window experts and provide guidance to the end users of how to cable up all different sorts of windows. Now, there are so many different window types out there. And whilst it technically works, there actually are some challenging windows. For instance, in apartments, often the window in question is a sliding glass balcony door, which are particularly difficult to cable up. Not impossible, but more challenging, more work. And when you've got large window frames, often you'd have like an openable panel and you'll have a static panel. And what we actually see is the end user typically will end up putting it on the openable panel, a bit that's actually more complex because that's nearer where the cable's going through the window. But we also then have a more fundamental issue, which is the end user perception. There are a number of users that just don't like the concept of a cable going through their window. And they'll cite concerns such as, oh, it makes my home less energy efficient because there's a breakage in the seal of my house. Or if there's a cable going through the window, doesn't that mean the window's not fully closed? Maybe my house is not as secure as it should be. So there are people basically just have this fear about pushing cables through. If we look at technician installation, there's some similar learnings that we have. We just focus on the cabling aspects for the technician installations. Here, the first one is the truck roll. So the cost of sending the engineer to sites to do the installation. Now, obviously, there's multiple things the engineer needs to do, but we're finding that the cabling work around the building and the drilling the hole and the cleaning up afterwards, etc., is taking up more time than installing the device. If we can actually reduce that time for all this cabling drilling work, it's real life savings and opportunities for the engineer to move on to the next house. If you're drilling holes through walls, you need access to the inside of the building. So now you need the end user to be present when the engineer's there. The engineer also has to have the right skill sets, to customer-facing skill sets, to go inside the house and bring his vacuum cleaner and tidy up and be nice and polite and all that sort of stuff. If the end user does not turn up when the technician does, obviously you've got no access indoors, it's a failed install. So there's more truck roll cost for the engineer to revisit at a later date. And there's still some negative perception about drilling holes through walls, because unfortunately not all technicians are equal, and many buildings have got historic cables coming through the walls, and some of that historic cabling coming through the walls is not a good example of what it should be, as some pictures I've put there. So again, there's a bit of negative perception there as well. So what if we could get from the inside to the outside without a cable? What if we could push power and data through the glass instead of opening the window and taking it through, or instead of drilling a hole? Yeah? How would this impact self-installation? Well, clearly, suddenly there's no cable going through the window, so all those customer perception issues have gone. There's all those cabling issues for all the different window types that are around, and there are a lot of windows, have gone. We now have the ability to put the device on the static panel of a large window as opposed to the openable bits. So the openable window can be used for what it's designed for, opening. You know? Like I said, there's a lot more flexibility. It's with a lot more compatibility, sliding glass doors, etc., etc. we suddenly now open up and remove all those issues. Now, it doesn't say that this will basically convince every customer to put it outdoors or for every customer to choose a better location in their home, but it's making life easy for them. This is all about making life easy for the end user to improve that self-installation experience. Similarly, from a technician point of view, we now give them an option that they don't have to drill a hole. So there, you can think about deployment scenarios where maybe actually the technician does all the work without having to schedule the end user to be present. Maybe they do the outdoor installation without the end user, and they leave all the indoor components at the building for the end user to install later when they get home. And kind of a mix between a professional install and a self-install, outdoor professional, indoor self. We also have an issue with professional install with drilling holes, like I said, because it's drilling a hole through an external wall, renters theoretically can't get that service. But now bypassing the fact that you actually don't have to drill a hole anymore, a renter could have an external professionally installed fixed wireless service. But this doesn't have to be fixed wireless specific, to be frank, on the technician install side of things. If we can have a solution where basically we can get power and data through the building without drilling holes, this could be used for fiber installations, an outdoor ONT, a cable broadband solution, a cable modem outdoors. So any telecom service where you put the access modem on the outside. And it could be used for other industries where, again, the end user is drilling holes through their building basically to get power and data through a camera, security camera, or a doorbell, etc. on the outside. So let's assume that we're adding Through-Glass to fixed wireless. What does it actually need to do from a power point of view? Well, the first thing, it needs to be agnostic to the different windows. We cannot predict what sort of window an end user will have at the time of selling a fixed wireless service. And most annoyingly, people have a habit of modernizing their windows over time. So we also can't predict what they'll buy in the future. So whatever solution you have needs to be able to adapt to all these different window types. And the permutations of glass options is amazing. There's a humongous number of permutations. From a power point of view, it needs to be compatible with self-installation. It needs to be low voltage. It needs to be flexible in different power levels, because some fixed wireless devices require a lot more power than others, like millimeter wave devices versus sub-6 only. Outdoor devices can last a long time. So any technology we're adding into those devices must also have a high MTBF and last a long time. And from a self-installation point of view, I mentioned this is all about convenience. So anything we're adding into it must be super, super convenient. It must be resilient to slight inaccuracies of the end user installing it. Again, we don't want more tools. We want it quick and intuitive. And there's lots of other things like energy efficiency, etc. But most importantly, also we're pushing power. When people think about pushing power, what we don't want is big electrical sparks. It needs to be safe for humans, pets, and other electronics. And of course, if we're removing a cable for power, then naturally we also have to think about the data. We don't want a separate cable for data, so we have to remove that as well. So we need a through-glass data solution that is just as flexible for all those different window types, but is also secure. We don't want neighbors listening in about the data that's going through your window. We also need coexistence. So if your neighbor's got exactly the same solution as you, we're not having your data's outdoor device talking to your indoor device and getting all mixed up. So lots of different things. We'll take some questions from Gabriel, and then after that, Willem will basically talk about how we can achieve these needs.
Good stuff. Thank you, Peter. We have a question or two in on the window technology and the different window types. We're going to hold that for a moment because Willem's going to go into it. Peter, terrific presentation. I certainly appreciate and really like your focus on making it easy for the user, the customer. I mean, I think oftentimes people want to blame the customer, but it's not their fault from their point of view. It's got to be nice and simple. A question though. Obviously, it's a bit of there's a commitment for you guys at NetComm to invest in and create this solution. What's the sort of market reaction from the carriers and ISPs and your customers essentially? What are the sort of feedback you're getting? What are they interested in? What's their what are their key asks?
Well, the goal of getting outdoors is quite a common one. So outdoor fixed wireless exists for a long time, but it's been very niche because of the truck roll. So, but most carriers are they've got radio experts in all carriers, and they know that actually outdoors is better for them, for the network, but it's been a challenge. Like I said, we've got some early movers who've done outdoor self-installation over the past few years who've been very happy, wanting to see improvements, but still very happy. But we've got a large number of carriers who basically want to take that step, and the cable has been their biggest concern so far. So there's a lot of people who are very eagerly looking at this for it to work because they are desperate. They're desperate basically to deal with the long-term capacity implications and the growth implications. They know that they need to get outdoors. Indoors has been a really good proposition to grow the fixed wireless so far, but it's not necessarily something that you can stick with forever.
Yeah, of course. So it's going to help them expand things. Great. Peter, stay with us. We're starting to get a bunch of questions come through. A good number of these are going to get answered in the next section. So, Willem, I'm just going to invite you to take us through the next few slides before we get to the actual Q&A. But please, Willem.
All right. Thank you, Gabriel. And thank you, Peter, as well, for describing the use case and the benefits. But you left me with a long list of requirements at the end. Thank you. Let me try to explain how we tackle those problems. And fortunately, we have been working on those for several years. Let's just first describe what needs to be done. We have a window, could be a wide variety of windows. And on the outside, there is an outdoor unit with a 5G modem integrated. Want to highlight that that box on the outside has no wires whatsoever. And this is something you really need to get used to, but it's very well possible to have a box without batteries that sits on the outside of a window and runs for years and years and years. On the inside, we have an indoor unit with obviously a power source. And what we need to do is first transmit wireless power to the outdoor unit such that the 5G can work and such that the electronics in general on the outside can work. But as important, we also need a wireless data connection to connect the data that the 5G modem receives to connect that with the inside. So power without data or data without power, both are pretty useless. You need both of them. That's why Solace, although our core business is wireless power, we have been working also on wireless data connections to prove the feasibility of both the wireless power and the wireless data. Now, I think everyone knows wireless power, for instance, from the Qi technology. I think many of you have used it for charging a phone, as an example. You may have noticed that to work, it needs to be pretty well aligned. Maybe as me, you also, from time to time, you have the situation that you wake up in the morning and thinking that your phone is charged, but it was not perfectly aligned and you have an empty phone in the morning. Can happen. Also very important, it can transmit up to 25 watts, which is quite a lot, but over only very short distance, around 2 to 3 millimeters. The Qi technology also uses ferrites to basically focus the magnetic field lines across the transmitter and the receiver. But there is an issue with that, at least in our use case. Ferrites, they lose their characteristic at higher temperatures. And as Peter explained, we need to deal with outdoor, and outdoor means extended temperature range and solar load on the outdoor unit. So ferrites can't use. The technology that Solace has been developing is quite different, as this clip illustrates. You see the distances are much more significant, and the alignment, is quite forgiving, as you can see. And maybe a way to describe the difference with Qi and other technologies, Those technologies are great within a confined environment, confined in the sense of transfer distance and misalignment, but the technology that Solace has been developing is extremely adaptive. It can adapt over distances, over metal coating, over misalignments. It's very adaptive, and it tunes itself to a wide range of environments. Also important to mention, we're talking about self-install. The technology will also detect if actually a receiver is present and not send any power in the case this is not connected. So needs also to deal with quite some safety items which are rather unpredictable when end users install stuff. This is the product. This is the Nova 30. It's roughly this size. I don't have particularly large hands, so this gives you an idea of the actual size. On the left side, you see at the bottom, you see the transmitter module, which is on the inside of the window, obviously. And you can see the coil, which is basically transmitting the energy to the receiver, which is on the top. Other side of the window, you can see has an equivalent receiving coil. The technology delivers up to 30 watts, so Peter, that's FWA plus. It can cover a very wide range of windows, and I will come back on that. It can cover distances up to 14 millimeters, and it really adapts to the type of window. For instance, it will not transmit more energy than needed to reach the other side. It does not include ferrites. That's forbidden for outdoor for this outdoor use case. Maybe an interesting one also to mention is that we're implementing the TR181 Broadband 12 Forum info model because this becomes a key element in the end-to-end connectivity between the end user and the network of the operator. So it's important that the operations conditions and possible faults and optimizations are reported into the ACS of the operator such that they can operate millions of those in the field. The dimension of this module is 85 millimeters, 35 millimeter thick. It's possible to use larger coils, and then you can increase the power and you can increase the distance that is being covered. Let's talk a bit more about the windows, the details of the windows that you're going to meet in real life. On the left, you see there's a wide variety of thicknesses of windows. There's a single pane, double pane, triple pane. For wireless power and similar for wireless data, the glass is quite transparent, so that's good. The toughest part is the low E coating. These are metal coatings. Again, they exist in a wide variety. There's hard coating, which is popular, for instance, in Canada. And then there are windows with single, double, triple layers of silver that is sputtered on the inside of the panes. It can be on the internal pane or on the external pane, depending if you want to keep the sun out or if you want to keep the heat inside the house. So a wide variety, and definitely we need technology that can adapt to all these. Let's talk about performance. On the left side, you see lab tests that we have been doing on a wide range of windows. You see all the different types of windows on the left. And you see that across all those windows, we can easily deliver 20 watts to the outside. And 20 watts, I think, is a nice ballpark number of what a sub-6 5G modem needs. That's actually plenty for sub-6 modems. Also interesting to get a bit of feeling of the statistics that you see of windows, and this is here on the right for the US residential market. You basically see that roughly 64% of them are double pane. There's still 30% of single pane, but that's gradually disappearing, and about less than 2% of triple pane. Basically, it means that if you look on the left chart of the picture, which is representative for both the red and the dark blue, basically we are covering 98% of all windows in the US with this. So I think, Peter, that's a tick in the box. I hope we can cover a very wide range of windows. The other part is the alignment. And when we started with this, we were quite worried on this because this is about self-installation, and people will definitely not perfectly align the box on the inside and the box on the outside. And it's also a bit complicated by the parallax of the window, which you're probably aware of. However, the technology is very forgiving. For instance, on the left, you see a misalignment of 10 millimeter, and you already see that this is not okay, but from a performance perspective, it's perfect. Even with the 20 millimeter misalignment, as you see now in the middle, the system still works perfectly. It's only when it really starts to look very, very ugly that you're going to lose power connectivity. So also there, Peter, a tick on the box. This is something an end user definitely can install by himself. So for the power, let's talk about the data connection. And when we talk about data, we immediately come into quite a wide range of different architectures that need to be supported. We'll not cover all of them, but let's maybe first look at the left one, which is by far...
Willem, sorry to interrupt you there, just as you're going on this section. We've had a couple of questions in which relate to the power section, which maybe we should take now, if you don't mind, just so that we're on topic here. I won't get to all of them right now, but one question is, with the module you displayed, is there an issue with any heat generated affecting performance? In fact, a couple of people have answered that, and I'll have one more for you.
Okay. No, I would say not at all. So basically, you transmit power through the window with a certain efficiency. The transmitter and the receiver, obviously, they create some level of heat, but that's all within the capabilities of an indoor unit, which can have vented ventilation, and an outdoor unit, which obviously has to be sealed, but which can radiate the heat outside of the box. So there are no weird levels of power dissipation that would forbid you of running this on a window. We've been running these for days on the windows. Actually, this summer I was running it on a reference house at 33 degrees ambient. No issues whatsoever.
Yeah. Okay. Another quick one on that. Well, I don't know if it's quick or not, but a quick question anyway. This is from an operator in Europe. By the way, I won't say your name or your company name when you ask a question, so you're confidential in that sense. The question here is, what is the automatic window optimization of the wireless power? You talked about automatic window optimization on slide 24. That's the one where your two modules are moving. So this person's just asking you to elaborate what you meant by automatic optimization, I think.
Yeah, so basically when you switch on the power, the system analyzes the window. Before it transmits any power, it will analyze what type of window it is, what level of metal coating, what the approximate width of the window is, and it will configure the system in such a way that it delivers the right amount of power that the receiver needs, and that will depend on the different type of windows and so on. It's the metal coating, the thickness, but obviously also the misalignment. If the system is misaligned, that doesn't work. Also very important, what I also mentioned, if there is no receiver present, which can happen, the end user does it in 2 steps, or the end user got a call and left for a while. During the startup, it will verify if the receiver is present and will not transmit any power if there is nothing to receive the power. So that's basically what the window adaptation is about.
Sure, we've got a bunch of other questions related to the physical deployment. We'll get to in a bit, hopefully, but I'll just let you go through again, a lot of people have questions on this data architecture as well. So back with you, Willem.
Okay, thank you. So let's first talk about the left side of this slide, which is by far the simplest to install. So basically 2 boxes, one on the outside, one on the inside, and just a power lead, and that's it for the installation. The outside has a 5G modem and a power receiver. The inside has a full Wi-Fi gateway, whatever the requirements are on that gateway. And obviously it has also a data connection to the outside. On the far right, you have what we could call the most universal solution, where the system which is on the window is only a virtual Ethernet connection. Virtual Ethernet in the sense that on one side, it transmits the data over the Ethernet to the outside, for instance, to the 5G receiver. And at the same time, it also delivers power over this virtual Ethernet through PoE to the 5G receiver. Maybe worthwhile noticing that this is great for fixed wireless access, but there are also plenty of other use cases possible here. The 5G box there could be a security camera, just to name one. And maybe another thing could be a Wi-Fi gateway to give you some decent Wi-Fi coverage on the terrace and in your garden. With those nicely isolated houses these days, 5G reception indoor is bad, but also Wi-Fi outdoor is pretty bad if you want to read a newspaper on your tablet outside. And then the middle solution is let's say, a hybrid, which basically is about using an existing home gateway. For operators, launching a new home gateway can be quite expensive. Integration in OSS BSS is rather takes time and can be rather expensive. And also having a home gateway at the center of the house can improve coverage. That can also be a reason to do so. At Solace, we have validated all these architectures. I will not talk about all of them. Let's focus just on the one which is easy to install, the one on the left. And this is a proof of concept that we did in the course of last year. Maybe first focus on the window. This is the reference house, and you see on the outside, we have the outdoor unit without any wires. You just need to get used to that. And on the inside, the indoor unit with the power, just a DC barrel. That's the only thing it needs. This is a technology validation, so we didn't pay too much attention to the size and the shape of the box. That's up to people, our friends of NetComm or other vendors in the industry to come with attractive enclosures, industrial design. What's inside the box is on the right. Obviously, we have the PTG power through glass transmitter and receiver to deliver power to the outside. We have a 5G modem integrated on the outside. And then for this validation, we have been using a Wi-Fi 7 access point, 3x3, 320 megahertz, and using a dual hop approach. We are basically using 6 gigahertz to get through the window, and then 5 or 2.4 gigahertz to get to the clients, which are spread through the house. And let's now focus in the next slides on the performance that can be achieved first to get through the window, and then secondly, end-to-end from the outside up to the client. So here we see the measurement done on that particular window. It's an AG2 window, which basically means you get an attenuation in the range of 25 to 30 dB between the outside and the inside. Technology is 6 gigahertz, Wi-Fi 7, 3x3, 320 megahertz. And as you already can see on the left, towards Peter's point of at minimum 1 gigabit and preferably 2.5 gigabit, you clearly see it's very well possible to get data rates in the range of 3.5 gigabits per second. Quite easily, I must say. You don't need large, high power, which basically means you can do this cost effective and with low power dissipation. Actually, we also have been testing Wi-Fi 6, 2x2, and with that, you easily get a gigabits per second. And for instance, you don't need eFEMs for that, which saves cost, which saves power. 14 dBm transmit power is plenty to get this done. And by the way, this also avoids interference with your neighbors, which is also something that Peter mentioned before. Of course, getting through the window is one thing. Second thing is getting from the window throughout the glass. And we've been testing this on this reference house, which I dare to say is a quite difficult house, 10 years old house with highly insulated. The north side, which is here at the bottom, and I'm not in Australia. North side, which is here at the bottom, is AG2 windows. The south side is AG3 windows. And the red box at the bottom right is the unit which you have seen the picture earlier. The intersections inside the home are also brick walls, so not dry walls, brick walls, which is quite challenging. But you still see that end-to-end through the window and up to the client. In the downlink, we get 800 megabits per second on average across that floor. And in the uplink, 400 megabits per second across the floor. And if you look to the current 5G services that are offered across the world, this covers most of it. So even with the Wi-Fi gateway all the way in the corner of the house, you get pretty good coverage with that. This was all about technology integration. We didn't look to look and feel. That's why we are happy that NetComm took the technology and did their proof of concept, the so-called teardrop, which is a pretty interesting shape. It uses the Nova 30 module inside, as we have been discussing. But maybe, Peter, you can say a few words about this and also where people can see this at Mobile World Congress.
Yeah, thank you, Willem. So, absolutely. So this is what we call the teardrop, as Willem said. So this is a POC device. So it's really focusing on technology as opposed to being a productized, commercially available product. So this has basically been going through carrier evaluations from a technology perspective over the past few months. It's been at CES, it'll be at MWC as well. We are obviously in the process of creating commercial products. The first commercial products will be going through carrier evaluation starting from Q2 onwards. So we're not talking about commercial products here. If you want to understand about them, come see us at MWC. So MWC, we've got a stand. In fact, Willem and the Solace team will also be there. So basically you can ask questions also. You can ask questions directly to Solace as well. In Hall 5, please come and see us and find out more.
Okay, good stuff. So we have 7 minutes for some Q&A. I have a bunch of questions already in. What I want to do though, first, Peter, if I go back to your picture here that you're showing, the teardrop shape, that's, I guess, a prototype of some sort. What do you think, how big's this thing going to be at the end, you know, through the design? We've seen a few in the deck here. We have someone asking, if I also add Wi-Fi to the IDU, will my device not get too heavy to put on a window? So I was just wondering if you could address like form factor, weight, you know, look and feel, that sort of thing.
So firstly, the teardrop is an eye-catching POC device. So it's not necessarily the commercial products that we're producing. So that's just answer that question. Now, as Willem shown, there are actually multiple different architectures of how the indoor side of things can work. Does it have a Wi-Fi gateway built into it, or is it an Ethernet based? If it does have Wi-Fi, is it purely the first point of a whole home Wi-Fi solution? So actually, your higher performing Wi-Fi gateway could be a standalone unit, and you're using meshing technology to connect to that. Certainly, what you don't want is Ethernet ports on your window, on the inside of the window, because that just gets ugly with more cables going to your window. So if you did have your gateway on the inside of the window, it's purely Wi-Fi only, and Ethernet you would leave to another unit in the home somewhere. In terms of weight, to be frank, the way that we do it with mounting on glass is we use gecko tape, and you can. There's videos on the YouTube where you can see people climbing buildings like Spider-Man using gecko tape. So you can get a lot of weight on here if you design it right.
Yeah, okay. So we've literally just had another European operator asking what kind of adhesive for fixing to the glass do you use? So it's gecko tape. And we have a lot of questions about how do you remove it? What happens if it accidentally gets knocked off? My own question is, what if I'm a renter and I move house mid-contract? I might want to move my FWA. My son's a student, for example. He's been moving a lot. Do you get condensation? There's loads of these types of questions coming in. Just tell us the physical kind of like, how does it stick there and stay there, and how do you get it off again? They seem kind of contradictory. I don't know. Okay.
No, so they're all very good questions. So when you look at on-glass solutions today, so NetComm, we have on-glass solutions, and there are other vendors of on-glass solutions today. By that, I mean things that stick to windows, not necessarily through glass, but on glass. There are some different choices that vendors use today. There are people that use adhesive pads. There are vendors that use suction cups. There are vendors that use gecko tape. And like NetComm, we're a firm believer in the gecko tape. The way gecko tape works is named after gecko lizards, which basically on the pads of their feet, they have many microscopic, I'm talking about millions and millions by millions and millions of microscopic pads. And essentially what you get is Van der Waals forces at an atomic level. And they're all very weak forces, but it's times by millions. So you end up basically with this, the atoms of the glass and the atoms of the pads attract to each other, but they're not actually stuck to each other. So basically you can take the pad off the window without, it's not like with glue, there's no adhesive that you're ruining and you can't reapply it. Basically the properties of the pad is still exactly the same as it was when it's taken off the window as when it's put back on. What you'd have to do is you have to apply it to a clean window. That's the most important thing for gecko tape, is cleaning the window first. But yes, if you peel it, basically the way it works with gecko, you can peel it off rather than pulling it directly off. It's very strong if you try to pull it directly off, but if you peel it off, it comes off quite nicely. And most importantly, it can be reapplied. So Gabriel, your question about if you move house, yes, a self-install on-glass solution you take with you. And it's not just for moving house. When you talk about on-glass solutions, I've mentioned before, people modernize their windows. So you can't have a solution that basically is reliant on adhesive pads or things that you can't put back on a new window.
Yeah. Okay, let me get one more question in for you, Peter. So this question, if one could put a gain in inverted commas amount in dB, how many dBs does this mini repeater typically achieve to get good signal into the building using RAN frequency? So I think you talked about 16 to 30 dB of attenuation through double glass windows. Is that essentially what we're looking at? I know it's not gain exactly, but that's the loss you're offsetting.
Yeah, well, I think in that question, I think the term mini repeater is very misleading. We are not repeating. We're putting the 5G modem, 5G antennas on the outside of the building. There's no repeating of 5G inside. When it comes to what we transmit inside, this is IP. This is Ethernet that we're transmitting inside through the glass.
Yeah.
Okay, so there's no 5G inside.
Let me get one more to you then, just because we've got time for one more. You talked about C-band and mid-band. What's your view on millimeter wave?
So the same through glass solution can be used for millimeter wave too. we can talk to the cows come home about the performance of millimeter wave and how it can be applied for fixed wireless, etc. But clearly with millimeter wave, outdoor is definitely better. So yes, if you want to do millimeter wave and you want self-installation or professional installation, you need to be looking at outdoor solutions, and anything you can do to make your outdoor solution better is what you should be looking at.
I'm going to hit you one more. Would this technology work with mobile applications? I'm thinking RV and marine applications. So I think RV, residential vehicle, like a camper van or a marine boat or something like that.
So yes, all the existing self-installed outdoor solutions are already used in those sorts of applications. So today we have cabled solutions, so small outdoor units with cables. They're already heavily used in those sorts of use cases. Through glass, obviously what we're talking about here is on glass. Sorry, through glass solutions. But yes, I don't see why they shouldn't be able to be used there.
Okay, that takes us right to the top of the hour. There's a bunch of questions we didn't get to, but as appropriate, I'll ask Peter and Willem to get back to you. If you're one of their competitors, they're probably not going to, just to set that up. But if you're one of the several operators who's asked a question, I'm pretty much certain they will do. By the way, the slides are also available for download from your console here. Just remains for me to say thank you very much, Peter Lewis from NetComm.
My pleasure.
And Willem Verbiest from Solace. Thank you, Willem.
My pleasure.
And with that, thank you very much and goodbye.